Recently, one of my GRE students asked me about this problem. You'll notice it's not in typical GRE format, and that's because it's from the Math Review chapter of the GRE official guide. I recommend doing these review chapter questions, even though they're not in standard format, because they are a great way to get up to speed on math fundamentals. Part A simply asks us for the area of ABCD. The formula for the area of a parallelogram is base times height. You can choose any side as the base, but let's choose the bottom side AD, which has a length of 12. So the base is 12, and the height is just the perpendicular distance from the base AD to the opposite side BC. And conveniently, we have a height already marked on the diagram. It's this line of length 4. We know it's a height because it has a right angle, which indicates that it's the perpendicular distance between these two parallel lines. So we know the height is 4, which means the area is 12 times 4, which is 48. Moving on to part B, which is a little bit harder, we have to find the perimeter of ABCD. And that's just the sum of the lengths of the sides. So we already know AD is 12. BC is also going to be 12 because opposite sides have equal lengths in a parallelogram. What about DC? Well, DC is the hypotenuse of this right triangle. So 2 squared, that's the square of one leg, plus 4 squared, that's the square of this other leg, equals DC squared. And we can solve for DC as follows. So putting that into our diagram, we have this line DC is 2 root 5, and on the opposite side of the parallelogram, side AB is also 2 root 5. So now we have every single length in the parallelogram. So the perimeter is going to be 2 12s, and we also have 2 of these 2 root 5 lengths. So 2 times 12 is 24, and 2 times 2 root 5 is 4 root 5. So that's our perimeter. And now we've come to C. It's asking us to find the length of this diagonal BD, and there aren't many tools for figuring out lengths, so it's likely we're going to need to use Pythagoras. One tempting avenue is to say, let's focus on BCD, this yellow triangle here, because it kind of looks like this angle D here is a right angle. But you can't really trust your eyes on something like this. I mean, maybe the angle is 88 degrees, and that's not good enough for us to be able to use Pythagoras on the yellow triangle. So, does this angle D have to be a right angle? Well, one way to think about this is to imagine what would happen if we shortened the base of our parallelogram, this side AD. Instead of being 12, let's make it shorter. And look what happens. It seems that when you do that, leaving everything else the same, the size of angle D shrinks, and this is pretty clearly not a right angle. So there's no guarantee that in our original diagram up here, that angle D is actually a right angle. So let's put this aside and try to find another right triangle that we can use. Well, one angle that we know for sure is a right triangle is the one that they've drawn for us, the one that's associated with this height. So let's draw the height again so that it comes down from BC and hits point D on the bottom side. Because this is a height, it's going to have a right angle here. So now what we've drawn is a new right triangle. Let me color it in for you. So this blue triangle here has to be a right triangle. And we know that the height of this blue triangle has to be 4. same as the height on the other side of this green rectangle. And as for the top leg of this blue triangle, well, here we have a 2 on our green rectangle. So up top on the green rectangle, the length also has to be 2. Now the full length of BC is 12, since BC and AD are opposite sides of a parallelogram. So this missing piece has to have a length of 10, since 10 plus 2 equals 12. And now that we have both legs of our blue triangle, we can find its hypotenuse BD, which I'm going to call x to make it easier to write out the Pythagorean equation. Okay, so we've got x squared equals 4 squared plus 10 squared, so that's 16 plus 100. There are 4 4s in 16 and 25 4s in 100, so that means we have 4 times 29. If we take the square root of both sides, x equals 2 square root of 29. And there you have it, the length of diagonal BD. Thanks for watching this video from Chiron Prep. I hope you'll subscribe to the channel, and if you have any requests, please feel free to leave them in the comments section.